Welcome to The Explainer. Today, we're going to pull back the curtain on the brain inside of AI, the neural network. We'll break down how these things are built, what they do, and by the end of this, you'll see how you could actually start building one yourself.
So here's the big question, right? How do you actually teach a computer, a chunk of metal and code, to think like a brain? Well, the answer lies in an architecture that's both incredibly powerful and, you might be surprised to hear, pretty simple at its core.
All right, so here's how we're going to break it all down. First, we'll look at the simplest part, the neuron. Then we'll see how you stack them up to build a deep brain. After that, get ready for a trip to the zoo of different AI architectures. It's pretty wild. And finally, we'll talk about how you, yes, you, can get started building one.
Okay, first things first, the simple neuron. Seriously, think of this as the single Lego brick. Every amazing, complex AI you've ever heard of, it's all built from this one tiny piece. It really is the heart of the whole system.
So, what even is a neuron? Well, it's basically a tiny little decision maker. It takes in some information, does a super quick bit of math on it, and then spits out an answer. That's really it. A simple input, a simple output. But trust me, this is where all the magic starts.
Now, not all neurons are created equal. They kind of have different personalities, and that's all thanks to something called an activation function. You've got the classic sigmoid, which is inspired by our own brains. It's like a smooth on-off switch. But these days, the cool kid on the block is ReLU. It's more of a zero or go function. If the signal's weak, it stays quiet. But if the signal's strong, it just lets it grow. It's super efficient, and that's why you see it everywhere now.
All right, so we've got our single Lego brick. Now, how do we build the castle? It's all about connecting them.
You know, one neuron on its own, it's not going to do much. The real power, the magic, kicks in when you connect thousands or even millions of them together. You stack them in layers, and suddenly the network can learn. It learns by tweaking the strength of those connections, figuring out which pathways are important for spotting patterns. That right there is the secret sauce.
And this is exactly how it works. It's so cool. You start with just one neuron, right? Then you line up a bunch of them to create a layer. Then you take that layer and stack another one on top, and another, and before you know it, bam, you've got yourself a deep neural network.
And that's what deep learning is all about. You know, it sounds super profound, but it's actually pretty literal. It just means we're using networks with a lot of layers, networks that are structurally deep, to learn really complicated patterns from tons and tons of data.
Okay, so now we get how to build a basic network. But here's the thing, it's not a one-size-fits-all situation, not even close. There's a whole ecosystem of different designs out there, each one specialized for a very specific job.
Yeah, someone described it as a zoo, and honestly, that's the perfect way to think about it. It's not one rigid thing, it's a zoo of possibilities. You've got all these different species of networks running around, each one perfectly adapted for its own unique task. And get this zoo is always expanding. This field moves so fast, researchers are literally cooking up dozens of new network designs every single year. They're constantly finding better, smarter ways to tackle problems. So let's meet a few of the star attractions in this AI zoo. First, you've got the CNN, or Convolutional Neural Network. This one is the undisputed king of image recognition. Then there's the RNN, the Recurrent Neural Network, which is amazing with anything that happens over time, like audio. And finally, the autoencoder, which is this genius little system for data compression. So, the CNN, how does it work? Well, imagine you have this little mask or window that slides across an image, patch by patch. At every stop, it's looking for simple stuff, an edge here, a curve there, maybe a bit of texture. And because it scans the entire image, it doesn't care where the cat is in the photo, it'll find it. This incredible ability is called translational invariance, and it's exactly why CNNs are so good with pictures. Next up, the RNN. I like to call this one the time traveler. See, most networks just push information forward, but RNNs, they have these feedback loops. This means information can circle back, creating a kind of memory. The network can remember what came before, which is absolutely crucial if you're trying to understand something like speech or music, where the order of things is everything.
And then we have the autoencoder. This one's really clever. It's a two-part system. The first part, the encoder, takes something big, like a high-res image, and forces it through this tiny information bottleneck. It has to compress it down to just its most essential features. Then, the second part, the decoder, has to try and rebuild the original image using only that compressed information. By doing this, the network is forced to learn what's really important about the data. It's a brilliant way to find the essence of something.
So we've looked at the building blocks, how to put them together, and we've even taken a tour of the incredible AI zoo. But now for what I think is the most exciting part of this whole story. This stuff isn't just for academics in ivory towers anymore. The tools to build this, they're in your hands, right now.
And this is probably the biggest thing to take away from all this. Actually designing and building these incredibly powerful models is becoming surprisingly simple. It's all thanks to a massive wave of open-source software.
You've got these incredible toolkits like TensorFlow from Google, PyTorch from Facebook, and Keras, which is famous for being super easy to use. These aren't just for experts. They're free, they're powerful, and they let literally anyone start designing and training their very own neural networks. You know, for the longest time, this kind of technology was locked away, accessible to only a handful of specialists. But that's all changed. The power to build an AI, to create an artificial brain, is now open to pretty much everyone. So the question isn't just how does it work anymore? The real question is, now that these tools are in all of our hands, what are we going to build?